Hi, this is Josh with trigonometric equations, 5 questions. Question number 1, for sine x plus 2 equals 0 for x equals 0 to 2 pi radians, which is the circle on the right. That's the reference unit circle. On the reference unit circle, x-axis is cosine x and the y-axis is sine x. For this equation, we would subtract 2 from both sides, and 4 sine x equals -2. Then divide both sides by 4, and sine x equals -1/2. Well, on this reference wheel, you should note that the sine of a half is 30 degrees, meaning that the sine of 30 degrees equals a half. But, however, since it's -1/2 and sine x is the y-axis, you see that the angles are below the y-axis where y is negative. For this, knowing that the reference angles hang from the x-axis, we have that occurring at 210 degrees, or 7 pi over 6, and 330 degrees, or 11 pi over 6. So the correct answers were 7 pi over 6 and 11 pi over 6 radians. Question number 2. For secant x plus 8 equals 0, for x is between 0 and 2 pi, well, subtract 8 from both sides and then divide by 4, and we get that the secant of x is -2. Well, since we have this wheel that uses the reciprocal functions of secant x and cosecant and cotangent, we can simply use this sine and cosine by doing the reciprocal. So the reciprocal of secant x brings us back to cosine x. So then we take the reciprocal of -2 and we get -1/2. So looking for locations where the cosine of x is -1/2, that occurs here at 120 degrees and also at 240 degrees, or in radians at 2 pi over 3 and 4 pi over 3. Notice again that here, since cosine is the x-axis, if we create the reference triangle for this unit circle, that would be this distance here along the x-axis, left of the origin. So the correct answer would be that that is the reference triangle, even though the secant of x is much larger. It's the ratio -2. The correct answer was 2 pi over 3, or 4 pi over 3. Those are the two angles. For further information, perhaps I'll do a video on Pythagorean, the Pythagorean identities. But remember that the sine squared plus cosine squared equals 1. That's the idea of this unit circle, even though the secant is an external triangle here. Okay, let's go on to the next question. Question 3. Here we have cotangent of x plus 3 equals 0. So add the square root of 3 to both sides. And then now we have the cotangent of x equals the square root of 3. Well, the tangent is cosine over sine over cosine, so the cotangent is the reciprocal. It's cosine over sine. Well, here we have, on the reference wheel, we have that ratio, the square root of 3, if we have the cosine √3 over 2 and the sine 1/2. If you set that up, multiply top and bottom by 2. Now we have the cosine is the square root of 3 and the sine is 1. So that is equal to the square root of 3. It also works in the third quadrant when both angles are negative. So there are two locations here, and also 180 degrees later, or pi to every pi degrees. We'll have that occurring. So that would be at pi over 6 and 7 pi over 6 radians. Those are the two angles for the cotangent that, when subtracting the square root of 3, equals 0. Question 4. If 3 cotangent squared x minus 1 equals 0 for between 0 and 2 pi. Well, this is kind of interesting because add 1 to both sides, and then the cotangent of x is a third. Well, I'm sorry, that's the cotangent of x squared. So I need that little 2 in there. Hold on a second. It's the cotangent of x squared. So then we square root both sides, And we get the cotangent of x is the square root of 1 over the square root of 3. Well, this is in reverse to the last problem. What we have here is, remember, cotangent is cosine over sine. So we want it to be 1 in the numerator and the square root of 3 in the denominator. And using the unit circle, you just multiply top and bottom by 2. And we have these 4 angles, pi over 3, 2 pi over 3, 4 pi over 3 radians, and finally 5 pi over 3. So there are 4 angles between 0 and 2 pi, where 3 cotangent squared x minus 1 equals 0. Question 5. Here we have, down at the bottom of the page, 2 sine squared x plus 5 sine x equals 3. Well, the way to solve these trinomial type equations is to do substitutions. Here I substituted in the letter A. I mean, you could use W or N or a different letter, but I chose A for the plugin for sine x. Then we have 2a squared plus 5a equals 3. Setting it equal to 0, it's 2a squared plus 5a minus 3 equals 0. And then we'll do some AC factoring here on the right. So a equals 2, b equals 5, and c equals negative 3. Then a times c is negative 6. And based on those factors, I mean, we can make a t-table, but the only values that are possible are like 1, 2, 3, and 6 for one factor. And then the other factor would be negative 6, negative 3, negative 2, negative 1, because they have to multiply to negative 6. So those are our category, are our candidates. And the only one that is true to that would be 6 and negative 1, because we want a 5. We want to find b. So now we're ready to rewrite. We're ready to rewrite this quadratic. And we can certainly write it as 2a squared. Since we have negative 1 and 6, I saw the 2, so I put the 2 with the 6. I mean, it works in either way. You can try it yourself, but it will still factor. We can do front back factoring the same. So then we have the front pair here, and we've split the middle. So what was 5a is now just rewritten as here it was negative 1 and 6, but in reverse order. So 6 went to the front, and negative 1 went to the rear pair, the rear couple. So there it is, and that's negative 1a. So that's equivalent to 5a in the middle, right? We're just rewriting it into 4 terms so that we can do the greatest common factor. So if there are possible rational solutions, here's one way of factoring it. And it does work here. Factor 2a from the front 2 terms, and we rewrite it as 2a times a plus 3. And for the back 2 terms, we had negative 1a minus 3, so factor out negative 1. And we have a plus 3 in the back 2 terms. Then create the new binomial, 2a minus 1, and we have 2a minus 1 times a minus 3 equals 0. Since we were substituting for a as sine x, we can now write down 2 sine x minus 1 times sine x plus 3 equals 0. Now we have it factored. Okay, so then we have to find the 0 products for the left factor and for the right factor. And we can see that 2 sine x minus 1 equals 0 means that 2 sine x equals 1 and sine x equals a half. The other solution, if you said sine x plus 3 equal to 0, you get sine x is negative 3. So that's extraneous because it's not in the range of sine x. So therefore, going to the wheel, this equation will work for pi over 6 or 5 pi over 6. Those are the 2 locations on the unit circle where sine of x equals positive a half. So the correct answers were pi over 6 and 5 pi over 6. I hope that this video was helpful for you in getting ahead in your mathematics learning and advancing your knowledge of mathematics. Thank you for watching my video.